So this demo that we're going to attempt to do is a demo we call the water cup. And it's a very simple demo, which means that we use it at a lot of our science outreach events. What that also means is that it is very easy to do at your own home. It only really requires these two materials. One of them is a glass of some variety that's able to hold liquid, whether it be a soda glass, a plastic cup, or in our case, a wine glass, which is good because it's got a nice, easy to hold stem. That is important. But pretty much anything that's able to hold a little bit of liquid and is nice and airtight, you should be able to get away with. And the other thing is a styrofoam plate. Now this one does need to be styrofoam. You can't do this with a paper plate or a plastic plate or a glass plate for reasons that we'll get into when we talk about the explanation for this demo. Now if we were to take our glass and put our plate on top of it, what do we expect to happen? The answer is that it just sits there. Gravity pulls down, the glass is underneath, nothing really happens. But if we were to flip it over, now what do we expect to happen? The answer is gravity pulls down, the styrofoam plate has nothing underneath it, so if I take my hand away, it falls down to the table. Now, obviously gravity is cool and all, but let's say we wanted to defy it a little bit. What if we wanted to, say, take this glass and fill it with a little bit of water? And when I say a little bit, I do mean a little bit. You probably don't want to fill it much more than a little inch or two of water. Anything more, there's a good chance of spillage, which is a good time to note that don't do this demo near any sort of electronic devices, because no matter how hard you try, you're going to spill a little bit of water, so make sure that anything you have nearby is nice and water resistant. So this time we take our styrofoam plate, we put it on top of the wine glass, and what do we expect to happen? Well, gravity is still here, so it still just sits on top. But now, if we apply a little bit of pressure on the other side of the plate, we flip it over, what do we expect to happen when I take my hand away? And the answer is plate stays. Now, when you're trying to flip it back over, no matter how hard you try, you're going to spill a little bit of water, so be aware of that. So what happened? I've obviously not floated off anywhere, so gravity is still clearly working, right? So what do you think made this plate stay stuck to this glass? Well, the answer to that is something that we call pressure. Now, whenever you have a gas, such as, for example, air, inside of any container, such as this room, or your lungs, or the inside of this glass, that air has something called pressure. It pushes outwards onto whatever container it's in. So when we put this plate on top, the air inside here is pushing on the glass, and it's pushing on the plate. Now, that in itself doesn't really explain it yet. But there's this thing with pressure where if you have gas in one higher pressure and another set of gas in a lower pressure, the gas in the higher pressure wants to go over to the lower pressure. It's sort of like if there was tons of people in this room. There's a bunch of people to my left, there's a bunch of people to my right. We were all really crowded together. And then I heard that outside in the hallway, there was nobody. There was like two people walking down the hallway, but otherwise there's nobody out there. Now, I obviously want to go out there because I want to have some space to, move around and not be surrounded by people. It's sort of the same thing with gas particles. They don't want to be inside tons and tons of pressure. They want to be in a little pressure. So when we put this plate on top and press in and flip it over, we actually create a smaller pressure inside of this glass than is outside in the room. So that gas in the room wants to go inside that glass, but it can't, because the plate is in the way. Now, that kind of explains half of it, but what about the water? Because if you'll remember, when we tried to do this without the water in the glass, the paper plate, the styrofoam plate actually, excuse me, just falls down. I know I had to push it a little bit because it's still a little bit wet, but you may remember from earlier in the video that it falls down. And the reason for that is that the water acts as a sort of seal between the glass and the styrofoam. So the air can't get in between the glass and the styrofoam, so it has to go through the plate. But because the plate isn't, able to be gone through, the air just applies a pressure to it and it keeps it attached to the glass. So now you know a nice little way to, impress your friends, and more importantly, you know how to explain it to them when they say, "How are you doing this crazy magic?"